So moving on to question 4 here, we have a binomial expansion question. So we're asked to find the first three terms for this expression here, given each coefficient in its simplest form. So you are actually given the formula for the binomial expansion in your formula book, but I've written it down here just to help with this question anyway. So don't worry about memorising it, it's already given. So let's have a go at tackling this. Pi, so 1 over 4, or 1 over the square root of 4 minus x. So we have to get it in this form, 1 plus x to the power of n, before we can start working out the actual expansion. Now notice this is 1 divided by the square root of 4 minus x. So how can we rewrite this? Well, the first thing that pops out to me is your rule of indices and negative powers. So we can write this as 4 minus x to the power of minus a half, because it's a square root. So minus a half. Like so. But now we need to just do an extra step as well. We need it to be 1 plus x. Or basically what we need is this 4 here to be a 1. So how do we make that 4 become a 1? We're going to apply a factor of 4. So if we pull that factor of 4 out, just make it, put an extra bracket and just make it clearer. This is what it's going to become. It's going to be 1 minus x over 4, because we took out that factor of 4. Like so. I've still got the power of minus a half. I should put a second bracket in there just to make it clear. There we go. Because this minus a half affects this 4 as well. So now what we actually have is 4 to the minus half times this expression here to the minus half as well. So we write this down fully. 1 minus x over 4 to minus half. Okay, so let's keep working through this now. We can actually use the expansion now. We've got it in the correct form, 1 minus x over 4 to the power of minus a half. So our n here will be minus a half, and our x is going to be x over 4, or minus x over 4 I should say. So what's 4 to the minus a half? Well, this is the same as 1 over 4 to the power of a half, and 4 to the power of a half is 2. So this is 1 over 2. Okay, so now we've got a half on the outside. Let's work out the expansion. So the first term is just 1. Okay, nice and easy, 1. Then it's plus n times x. Well, n is the power here, so minus a half. So this is 1 plus. So use brackets here, guys. It makes life a lot easier. So this is minus a half, and we're timesing this by the x, which is minus x over 4. So minus x over 4. Now we're going to add on again, because we're plus in here, and then we're going to do n times n minus 1 divided by 2 times x squared. So n is just again your power, so minus a half. And what would you get if you take 1 off minus a half? So that'd be minus 2 over 2, so that'd give you minus 3 over 2. That's minus 3 over 2. And then don't forget we divide this bit by 2 here. So that's divided by 2. And then we times it by x squared. So that's minus x over 4 all squared. That's x over 4 squared. So these are our first three terms that we actually need to work out. So let's just keep simplifying here. So this is a half again, times by 1. Plus, so if you just simplify this, this is minus a half times minus x over 4. Minus times minus, that'll become positive. So it's going to be 1 plus this 2 times 4 will be 8, so x over 8. Again, all we need to do is keep simplifying. So what you've got here is minus a half times minus 3 over 2. So that would be 3 over 4. But then don't forget we're dividing by 2. So if we're dividing by 2, same as times it by a half. So this would be 3 over 4 times by a half will give you 3 over 8. And then you're going to times it by x squared over 16. So in total, that's going to give you 3x squared plus 3x squared divided by 128. Divided by 128. And then just simplify this, we're timing it through by a half. So what are our final terms? That's a half. X over 16 plus x over 16. And 3x squared over 256. And there we have it. That is our binomial expansion for 4 marks. So that's the job done for that part. And then B, part 1 and 2, there's 1 mark because dead quick. It says state given a reason which of these 3 values of x should not be used. So basically these expansions can be used to find an approximation to the square root of 2. And we're given 3 possible values that can be substituted. So x is equal to minus 14, x is equal to 2, and x is equal to minus a half. So remember how you validate the binomial expansion and what values it's valid for. So this is going to be valid, so I'll just put v when. So it's going to be when the modulus of our x value. So our x value is this x over 4 here. So valid when x over 4 is less than 1. Okay, let's keep simplifying this. So we can pull this denominator 4 here out and times through. So this is going to be the modulus of x when it's less than 4. So we can rewrite this as the inequality given here. So x is between minus 4 and 4. So the x value has to lie between this range. If it's bigger or smaller, then it's not going to be valid for it. So straight away, the first one, x is equal to minus 14, we can't use it. So therefore, so this is part 1, the value that shouldn't be used, x is equal to minus 14. We don't want that one. That's the one we do not want. So for part I, it's x equals minus 14. And then so I'll do it over here because we're running out of room. Again, it's just a quick 1 marker. It says state you in a reason which of these 3 values of x would lead to the most accurate approximation to the square root of 2. So for this question, you've just got to understand how we get the best approximation. And the best approximation is the smallest x value, the one that's closest to 0. So we look at our 3. Well, this one we can't even use, so it's between x equals 2 and x equals minus a half. So clearly it has to be x equals minus a half because it's closer to 0. So therefore, x equals minus a half because it's closer to 0. So closer to 0. I know that doesn't even look like English, but yeah, closer to 0. So there we have that question for them.